All right, David Gann here with another question from your Hayes and Harris Math SL textbook. This is Chapter 2E.4, Question 7, and this is a good one. We have the second term of a convergent geometric series. It's 8 on 5. Now the sum of the series is 10. And we want to show that there are two possible series, and we want to find the first term and the common ratio in each case. Wow. Okay, well, let's start with what we know. We know that there's information about the sum of this convergent geometric series. So this is the infinite sum of the convergent geometric series, which means that the first term divided by 1 take the common ratio should equal 10. This also means that the absolute value of the common ratio has to be less than 1. So r has to be greater than -1 and less than 1. So somewhere between there. We know this must be true. We also know that the second term in the series, or in the sequence, is 8/5. Now, we need the first term, or information about the first term. So we need to somehow convert this into information about the first term. And we'll do it using the general term for a geometric sequence, which is the first term multiplied by the common ratio to the power of n minus 1. Now we're going to let n be equal to 2 so that we get the second term. So this gives us the second term, which is 8/5 must be equal to the first term times the common ratio to the power of 2 take 1. That's 8/5 is equal to the first term times the common ratio. This gives us a relationship between the first term and the common ratio, just like we have over here. That's what we're going to need, because we have two unknowns. So we need two equations to solve for two unknowns. Let's see if we can use a substitution here. We're going to solve this for u1. So u1 is then equal to 8/5 on r, which simplifies to 8 on 5r. We'll take that result and we'll bring it over here. Now the sum I know is 10, that's given in the question. That's equal to u1 on 1 take r. But I know what u1 is. So I can substitute in. 10 is equal to 8 on 5r over 1 take r. We just need to solve this for r. So we'll start by taking 1 take r, multiply it across to the other side, and we get 10 times 1 take r is equal to 8 on 5r. Multiply by 5r, and we get 10 times 5r, that's 50r, times 1 take r is equal to 8. Distribute in. 50r times 1 is 50r. 50r times -r is -50r squared is equal to 8. Okay, now I start to see why there are two solutions, because I have a quadratic. And anytime you have a quadratic, you have the potential for two solutions. You can have 2, 1, or none. I'm already told that there are two, so I know that this has to solve with two solutions. So to solve this for r, I need to use my quadratic tools. My quadratic tools tend to work best when I have this solved for 0. So I'm going to move 8 to the other side. And I'll get -8 plus 50r take 50r squared. Now just as a personal preference, I don't like having the r squared term on the end. I like it having it in the front. So I'm going to multiply this all by -1. -50r squared becomes positive 50r squared. Positive 50r becomes negative 50r. And -8 becomes positive 8. 0 stays 0. 0 times -1 is still 0. Now I have a quadratic. I can try and factorize this. Just in my gut, it doesn't look pretty. I think it's going to be a real brain buster to try and factorize this, if it even factorizes well. So I think my first instinct here is to go for the quadratic formula. Quadratic formula, of course, says that r is equal to, solve this for r, -b plus or minus the square root of b squared minus 4ac all over 2a. What are a, b, and c? The coefficient of your r squared term is a, the coefficient of your r term is b, and your constant term is c. So this means that r is equal to negative b. Well, b is negative 50, so negative 50 is positive 50. Plus or minus the square root of b squared. Negative 50 squared. Take 4 times a, which is 50, times c, which is 8, all over 2 times a. All right. 50 plus or minus. Negative 50 squared is 2,500. 4 times 50 is 200. Times 8 is 2,000. Is it? 200 times 8. No, 1,600. All over 2 times 50. That's 50 plus or minus the square root of. This difference here, that's 900 divided by 2 times 50. And now we need the square root of 900, which is 30. I don't need to worry about the plus or minus because it's built into the formula. We'll divide that by 2 times 50. 2 times 50, I probably should have calculated at some point, is 100. All right, so what do we have? We have two solutions. We have 50 plus 30 is 80, divided by 100 is 0.8. And 50 take 30 is 20, divided by 100. That's 0.2. So r is equal to both 0.8 and 0.2. That's my two solutions. This means I'm going to have two different first terms based on which r I choose. Now remember, going back to the beginning, we already determined that the first term is 8 on 5r. So let's bring that back. u1 is 8 on 5r. So let's let r be equal to 0.8, and let's let r be equal to 0.2. And I'll get two different answers for the first term based on the value for r. So we're going to take our result, bring it over here now. u1 is then 8 on 5 times 0.8, or it could be 8 on 5 times 0.2. That's 8 on 4, that's 2. That's 8 on 1, that's 8. So this is now our pairs of solutions. u1 is 2 when r is 0.8, or u1 is 8 when r is 0.2.